Okay, so today we're talking about Pascal's triangle, okay, and binomial expansions. What does bi mean? Two. So we're talking about two terms being expanded. It's not supposed to be funny, okay? Two terms being expanded. Yeah. So this down here, if you look in the bottom here, this is Pascal's triangle. I also have Pascal's triangle in my classroom posted on that blue chart over there where it goes down to like a lot of rows. Okay. So on this first one, what you have to do is we have to multiply this out to find out what the answer is. Okay? And we're going to kind of do it the long way here for a minute, but then I'm going to show you guys a shortcut. Okay? So if you have a plus b to the first power, what is that answer? Good. So the a plus b goes right here. Okay. If I have a plus b to the second power, how do I find that answer? You can do your box. Exactly. So let's go ahead and do that to the side here. So I'm going to make a box. And we have a and a b and a and a b. And when I multiply a times a, I get a squared. A times b is ab. A times b is ab. And then b times b is b squared. So if we are simplifying this, we end up getting a squared plus what? Plus 2ab plus b squared. So we're going to write this answer right here where it has these three terms. So we have a squared plus 2ab plus b squared. Okay, so how will I then find the answer to a plus b to the third power? Yeah, so you're going to do a 3-box because it's a plus b times a plus b. No, it's not a 3-box. Well, it's kind of. It's a 3 by 2. 3 by 2. Yeah. Because I already found out what a plus b squared is. So I'm taking this answer right here and multiplying it by another a plus b. Does that make sense? So I already know what the squared answer is. So let's go ahead and make a box that is 2 by 3.
There isn't an easier way to do it?
There is, and I'm going to show you after this one, okay?
I don't like drawing boxes.
Okay, I hear lots of little side conversations, and I really want them to stop. So when you continue to have side conversations, it's telling me that this is not a very good seating arrangement, and you want me to make the seating arrangement for you. Okay, so if that is not the case, then you need to be quiet when I'm teaching a lesson.
I have a question. Where did you get the top row from?
It was from here, a plus b squared. Remember I multiplied 2 a plus b's out? And I got that answer? So now I'm just taking this and I'm multiplying it by another a plus b to make a plus b to the third. Okay, so a times a squared is a to the third, good, or a cubed. A times 2ab would be, very good, 2a squared b. A times b squared is ab squared. B times a squared is, good. And 2ab times b is, and lastly, b times b squared is. Now remember that your diagonals usually always line up. So if you notice, these are both a squared b terms, and these are both a b squared terms. So when I write that answer, I get a to the third, and then this is 2 and 1, which would make plus 3a squared b, and then the next one would be what? 2 plus 1 is, so plus 3ab squared, and then I have plus b cubed, b to the third power. Okay, so when I write this all out, we're going to write it in this line. Notice that there are 4 terms here, and there are 4 blanks here. So I have a to the third power plus 3a squared b plus 3ab squared plus b cubed. Okay, so I want you guys to look at these. Does it feel warm in here?
No. It feels perfect.
So I should not do this one? No. So you did whatever you did. Okay, so I want you to look. There's like so many patterns in this, okay? I'm going to help point some of them out. Are you guys ready? Okay. So this one has a first power, and there are how many blanks? 2. This has a second power, and there are 3 blanks. This has a third power, and there are 4 blanks. This has a fourth power, and there are... So how many do you think would be if it was a fifth power?
6.
If there was 10, there would be...
11.
Okay, so we... Okay, this is a first power, and there are 2 blanks. This is a second power, and there are 1, 2, 3 blanks. Third power, and there are 1, 2, 3, 4 blanks. Fourth power, and there are 1, 2, 3, 4.
So wait, are you trying to tell us like?
So what I'm telling you is that whatever power this is, there's going to be how many more blanks? 1 more blank than there is your exponent or power. Okay, do we see this? Okay, now, in Pascal's triangle, and I want you guys to kind of look at this, this first row right here is basically like row 0. Okay? It's like anything to the 0 power equals 1. Okay? Along all the sides are always 1s. Okay? And then what happens is to get to your next row from row 1, so we have a 1 and a 1, because 0 plus 1 is 1. 1 plus 0 is 1. Okay? If there were zeros on there as well. So when you go here, we have a 0 plus 1, which is 1, but 1 plus 1 makes 2.
I'm so confused now.
Okay? I'm going to get a... You too, thank you. Okay, so again, the first row, you always start with 1, and you're always going to have 1s along each of the outsides. Okay, now what happens is, so after this 1, you get 2 more 1s, because they're all along the outsides. And basically this is saying 0 plus 1 is 1. And 1 plus, if there was a 0 here, 1 plus 0 is 1. Okay? When you go to the next row, what happens, and again, we always have 1s on the outside. Here you go, 1 plus 1 makes...
Oh, you're making a triangle.
2, exactly. And then we have another 1 on the outside. Okay, stay with me. Okay, so when I go to this next row, if we look at it, again, 1 is on the outside. And then you go here, because it's always these 2 add down to this one. So 1 plus 2 is 3. 2 plus 1 is
3.
And this is also 1. Okay, so on the next row, we always start with 1, right? 1 here, 1 plus 3 makes 4. 3 plus 3 is 6. 3 plus 1 is 4, and then you have a 1 on the outside. So on the next one again, here we go. 1 plus 4 is 5. 4 plus 6 is... Okay, hold on. 6 plus 4 is 10. 4 plus 1 is 5, and then 1. All of these are like if you had zeros out here, okay? Because these could all be zeros. 0 plus 1 is 1. But we don't usually write the zeros. Okay? Okay. Now, do we understand how Pascal's triangle works? Okay, now we're going to go back to what we've already done. Okay. I'm going to add a couple numbers here. This A is really 1A and 1B. Do you guys agree? On this next row, this is really 1A squared, 2AB, and 1B squared. Correct? This one is really 1A to the third, and then we have 3A squared B, 3AB squared, and 1B cubed. Do you guys see a pattern?
No.
No. Okay. Do you guys see it or no? We're correlating. So look, this was a first power. Remember how I told you this is basically row 0? This is really row 1. So when we had AB to the first power right here, see how I have 1A and 1B? Look right here. 1 and 1.
Where do you see 1 and 1 at? Down there. Okay.
See how that's 1 and 1? So then this next row, and how to remember the rows is like the second number tells you the row. So this is really row, okay? What?
The second number in. I did it.
Oh, good. Okay, so this is row 2, and look, when you go to this one, when it's a 2 exponent, it goes 1, 2, 1. 1, 2, 1. Do you guys see it? So when we go to the third power, the third row, third power, it goes 1, 3, 3, 1. 1, 3, 3, 1. Do you guys see this? Do you see how this third power, gentlemen, it does not look like you're listening to me. This third power goes with, this is row 3. Remember, it goes 0, 1, 2, this is row 3. Basically, the second number tells you what row you're in. Okay? So if you have the third exponent, the numbers in front here, the numbers in front match the third row in Pascal's triangle. Okay, so see how this is the third power, this is our third row, and see this number goes 1, 1, 3, 3, 3, 3, 1, 1. See it? Yes. So what are going to be my numbers with my fourth row? What are the numbers that are going to be in front here? 1, write them down. 1, 4, 6, 4, 1. Are we all okay with that?
Yeah.
Okay, now for dealing with the A's, okay? If you notice here, see how this is a second power? Here? A started as a second power. Then it goes A to the first power, and then this would be A to the 0, but it's not there because it's 0, correct? If you look here, this is my second term. Here it's B squared, and then it goes B to the first, and then there's B to the 0. Okay, so we go to this one. See how it's a third power? A starts as A to the third. Then you have A to the second, and then you have A to the first, and then you have A to the 0, which is not there. And then same with the B's. B's go the other direction because B's come last. Okay, so we have B to the third power, B to the second, B to the first, and B to the 0.
Wait, so on the next one it's going to be 1A to the 4th?
Yes. Okay, wait, I want to show you more patterns first. Hold on. Okay, Vienna. So do you see how this is a third exponent? Yeah. A is your first term, okay? So your first term that's here starts here, and you have A to the third. And then you go down by 1. A to the second, A to the first, and then you do your last term, which is B. So this is B to the third, B to the second, B to the first.
If there was 2 B's after that, B to B to the second, and then oh no, it goes that way and then back.
Yeah, and there's one other thing I want to show you, another pattern here, okay? So this is our third power, right? Joey, right? This is our third power. So here, my exponents need to add to be that. So see how this is A to the third? Okay, so that's 3. What's 2 plus 1 in my exponents equal? 3. What's 1 plus 2? 3, and this is third. So your exponents on each individual problem should also add to be that one. Do we see this?
Always start off with A.
No. And we're going to practice them. Okay, this is like basically showing you the generic equation of this. Okay, so we have all our numbers. Did you guys already write the A's down now? Yeah. So what am I going to start with on this one with the A's? A to the fourth, and then A to the third, and then A to the second, A to the first, and then A to the 0 I don't write. And then I'm going to go backwards now. This is B to the fourth, B to the third, B to the second, B to the first, and no B's. Yeah, so your first term has no B's and your last term has no A's because it's really B to the 0 and A to the 0, but we don't write 0 powers, okay? So I want you to try to do your fifth row on your own. I'm going to give you about 30 seconds. And I'm just going to stop this.